Hello, my name is Carlos, and with the help of my co-authors, we made the SST Testbed. The SST Testbed is a platform for users to test network attacks and defenses on their own programs on embedded systems. Network attacks, like the Murray botnet, are a growing problem for IoT devices because they're connected to the internet and people use them all around their homes. The testbed was created to address that problem. The testbed was also created to address the lack of open source testbeds for testing network vulnerabilities, tailored towards embedded devices that are resource constrained. The novelty of the testbed is that it fills that void. It's a platform for simulating network attacks on embedded systems. It uses a customizable input file for ease of use and to give the user an easy way to test different attacks quickly. Along with that, the setup and execution processes are simple to make sure it is as user-friendly as possible. The impact is that it creates a safe environment for people to test their code before actually deploying it and being vulnerable to attacks. The testbed also offers hands-on training for people to learn how to deal with network attacks and people who are wary of using IoT devices because they think they still lack sufficient security might be more likely to adopt these devices, since a safer standard for these embedded devices will allow for a broader audience to be able to use them safely. The network attacks the testbed currently supports are the replay attack and multiple denial of service or DOS attacks. The network architecture behind the testbed is Secure Swarm Toolkit, or SST. SST is a network architecture that provides embedded devices with key distribution mechanisms. It accomplishes this by having its own key distribution center called auth. Auth provides authentication and authorization to the devices in the local IoT site and acts as a bridge of authorization between these local entities and the internet. Before going over the design of some of the DOS attacks, I want to first go over setting up the testbed. To set up the testbed, the user will need to do the prerequisites, which will have them install and compile SST. Once that is finished, the user can then compile the testbed code, which can be found in this directory and is pulled up in this separate terminal. The user will then just need to run these three commands. Once that is finished, the testbed is now set up. The first step will be for the user to set up the configurations by running this setup script. That script can be found at the bottom of this README. The first step is to go to this directory. The next step is to run this command. And then we will run that setup script. The setup script has two arguments. The first is a required one that determines the number of clients the auth and server will be configured to take in and accept. The second is an optional password that will make running the setup script slightly faster. So we will just do the number of clients argument. I'll set that to 3 to keep the terminal clean and simple. We'll ask for that password. And then it will open a separate terminal window for the auth, and we'll ask for the same password. Here it is. Now that is running, and the script has finished executing. The script sets up the configuration by creating the configurations for the auth and server. To do that, it runs a testbed generator that runs these two JavaScript files. And those files create a graph file, which determines the network topology of the auth, and it creates these configuration files, which will be used for running the clients. That graph file is used for this auth and credential generator that creates the auth server and the credentials for all the clients. Once that setup script has finished running, we can then run the clients. However, it still requires an input file that will determine what attack type will be done in that execution. In the execution, the client will attack either the auth or the server, which is also created by the run client script. And that attack type is determined by the input file as mentioned earlier. The deployment of this attack can be in a simulated environment by using NS3, or it can be in a real local environment using physical embedded systems. Here is an example of the attack on the key distribution center, or auth. The user will first need to run the clients. To do that, it will require an input file, which can be one of the pre-made ones in the testbed, or the user can make a custom one that, as long as it follows the correct format, can be used as a valid input file for the run client script here. That script will first generate the clients, and those clients will launch an attack on the key distribution center by doing a large amount of session key requests. Here's a demonstration of that attack. First, we will run that script. And the script has two required parameters. The first is the number of clients that will be used during the attack. I made 3, so I will use all 3. Second is the input file that will be used. The input file determines the type of attack, and as you can see here, it's a very simple and straightforward format so that the user can easily use and understand it. We'll navigate to that file. As you can see, 4 terminal windows opened, 1 for the server, and 3 for each of the clients that I used. You can see they are all doing a large amount of session key requests. Successfully finished. The server also successfully finished after all clients is connected. And that is the session key request attack. Next, I will show an attack on the server. To do that, the user will need to run the clients using the run client script again. We'll take in an input file, and the script will generate the clients, and the clients will attack the server by sending a large amount of secure messages. To demonstrate that attack, we'll go back to the same directory as before, use the same script, and we'll use 3 clients again, but this time the input file will change. Although it looks very similar to the last one, the details that distinguish the attack type are in the README. For now, we just need to know that this file will send a large amount of secure messages to the server. We'll then navigate to that file, and then we'll once again open 4 terminals, 1 for the server. Here you can see it's receiving all the client messages, which have already finished. And then we'll launch 3 client terminals. First one sending messages, second one send messages, and third one also send messages. And that is the send secure message attack on the server. Now I will show an attack on the auth via the server. The user will first run the run client script, which will take an input file. The script will generate the clients. Then the clients will attack the server by attempting to connect to server a large amount of times. And the server will actually attack the auth or key distribution center by trying to request a large amount of session keys based on the number of times the clients attempt to connect to the server. Here, the clients are using the server to attack the key distribution center. So one way to defend against this attack is to add rate limiting to the server so that even though it is receiving a large amount of connections to the server requests, the server will not request a large amount of session keys to the key distribution center. That way, even if the server is being overloaded by a large amount of connection to server requests, the server will not overwhelm the key distribution center. To demonstrate this attack, we'll go back to this directory, run the same script as before. We'll use 3 clients again. We'll use a different CSV file. Again, very similar to the last ones, but a slight difference. Change the attack type. We'll navigate to that file. Launch it. 4 terminal windows total open. As you can see, the attack stopped because the server closed. You can see that here. All the clients connect and the communication systems finishes on the server side, but on the client side, all the requests were not sent because the clients sent too many requests to the server. So in this case, it is a successful attack by the clients to overwhelm the server. And that is the attack on the auth via the server. To summarize, the novelty of the SST Testbed is that it is an open source, easy to use platform for testing network attacks on embedded and IoT systems. The impact of the testbed is that it creates a safe environment for testing, training individuals on IoT security, and increases the standard of security for aware individuals who are unsatisfied with the current state of IoT security and may want to adopt an embedded device in the near future. The attacks that are currently supported by the testbed are replay attacks and DOS attacks. The defenses for those attacks can be implemented by the user, and in the future, defenses will be implemented directly into the testbed for users to learn from, use, and experiment with. That is the SST Testbed. Thank you for watching.